Hello students, welcome in e-learning class of Sant Michael's Academy. Students, in previous videos we have already discussed about addition, subtraction, multiplication and division of complex numbers. Now, in this video lecture we are going to discuss about some identities of complex numbers. So let us start our video. Students, let Z1 and Z2 be any two complex numbers. Let Z1 and Z2 be any two complex numbers. Then, first identity is Z1 plus Z2 whole square. Whole square of Z1 plus Z2 equals to square of Z1 plus square of Z2 plus 2 Z1 into Z2. Second identity is whole square of Z1 minus Z2. Whole square of Z1 minus Z2 equals to Z1 square plus Z2 square minus 2Z1 into Z2. Third identity, Z1 plus Z2 into Z1 minus Z2 equals to Z1 square minus Z2 square. Fourth identity, Z1 plus Z2 means whole cube of Z1 plus Z2 equals to cube of Z1 plus cube of Z2 plus 3 Z1 Z2 square plus 3 Z1 square Z2. And fifth identity is Z1 minus Z2 means whole cube of Z1 minus Z2 equals to cube of Z1 minus cube of Z2 plus 3 Z1 into Z2 square minus 3 Z1 square into Z2. Students, these are identities of complex numbers when Z1 and Z2 are any two complex numbers. Then Z1 plus Z2 means whole square of Z1 plus Z2 equals to square of Z1 plus square of Z2 plus 2Z1 into Z2. Second identity is square of Z1 minus Z2 equals to square of Z1 plus square of Z2 minus 2Z1 into Z2. Third identity is Z1 plus Z2 into Z1 minus Z2 equals to square of Z1 minus square of Z2. Fourth identity is whole cube of Z1 plus Z2 equals to cube of Z1 plus cube of Z2 plus 3 into Z1 into square of Z2 plus 3 into square of Z1 into Z2. And our fifth identity is whole cube of Z1 minus Z2 equals to cube of Z1 minus cube of Z2 plus 3 into Z1 into square of Z2 minus 3 square of Z1 into Z2. These are identities of complex numbers. We can prove these identities. So let us discuss how we can prove these identities. First of all, I will prove first identity, which is whole square of z1 plus z2 equals to square of z1 plus square of z2 plus 2z1 into z2. This is very easy to prove. z1 plus z2. First of all, we will write whole square of z1 plus z2, and we can write whole square of z1 plus z2, z1 plus z2 into z1 plus z2. We can write whole square of z1 plus z2 equals to z1 plus z2 into z1 plus z2. Now, z1 plus z2 into z1 plus z1 plus z2 into z2. We will multiply z1 plus z2 by z1, then after z1 plus z2 by z2. Now again we will multiply z1 plus z2 by z1, and this will equals to z1 into z1 plus z2 into z1 plus. Now I will multiply z1 plus z2 by z2, and this will be equals to z1 into z2 plus z2 into z2. We can write z1 into z1 equals to square of z1, and this is z2 into z1, and this is also z1 into z2. This both are same. We can write z2 into z1 plus z1 into z2, and these are same. And we can write z2 into z2 square of z2, and z1 square plus 2 z1 into z2 we can write, because these are same thing. We can write z2 into z1 as z1 into z2. So after addition we will get 2 z1 z2, and this is z2 square of z2. In this way we have got our first identity, z1 plus z2. Whole square of z1 plus z2 equals to square of z1 plus square of z2 plus 2 z1 into z2. And in this way we can prove all other identities. Let us solve some problems. Students, one problem is there, that is we have to find five minus 2i, means square of 5 minus 2i. We have to find square of 5 minus 2i, and this is very easy to find out square of 5 minus 2i, because we have discussed that if two complex numbers are there, suppose z1 and z2 are two complex numbers, then square of z1 minus z2 equals to square of z1 plus square of z2 minus 2z1 into z2. And here same situation is there. We have to find 5 minus square of 5 minus 2i. Students, suppose this is z1 and this is z2. 5 is a real number But you should know every real number is complex number. Every real number is complex number, and this is also this is a complex number. 2i is complex number because I is together with 2. 2 is real number and I is together with 2, so 2i is a complex number. So 5 5 is a complex number and 2i is also a complex number. So suppose 5 is Z1 and 2i is equals to Z2, and then after we will use formula whole square of Z1 minus Z2 equals to square of Z1 plus square of Z2 minus 2Z1 into Z2. Then after we will get square of 5 plus square of 2i minus 2 into 5 into 2i. Now, square of 5 equals to 25, square of 2i. So first of all, square of 2 equals to 4 and square of I minus 5 to the 10 and 10 to the 20i. Students, since we know square of I equals to minus 1, and earlier we have discussed about it, square of iota I equals to minus 1. So we will put this value here, 25 plus 4 into minus 1 minus 20i, and this is 25 minus 4 minus 20i. 25 minus 4 equals to 21, and this is minus 20i, and this is also a complex number. This is real part and this is imaginary part. This is imaginary part of complex number, and we have got our result, square of 5 minus 2i equals to 21 minus 20i, which is also a complex number. I hope students you are getting. If there will be any doubt, you can ask in comment box. Thanks.